Today's talk is going to be about high-performance serverless functions with Scala. It's great to be here at Scale by the Bay. So, hello, Scale by the Bay. Wait a sec. No, that's San Francisco, right? All right. Hello, Scale by the Bay in Oakland. Thanks for coming to my hometown. Makes it easier for me. This works out really nicely. It's a beautiful venue, isn't it? Yeah, really liking it here. All right, so this is going to be a talk about serverless functions in Scala, specifically, whoops, I just like pressing that, specifically about AWS Lambda. So I want to focus on AWS. I know we have Google Cloud and Azure and other ways to do serverless. This is going to be AWS specific today. All right, so November 14th, we're all set. Well, to start off, I kind of like to tell tales when I give technical talks at developer conferences in Masonic temples in Oakland, usually. I like to talk about one of my favorite tales, Vanilla Sally and the Growling Lambs, but you probably already know it, right? Who knows this story? No? Anyone? All right, I'm going to go over to the other side. Anyone here know the story? Oh, Vanilla Sally? Growling Lamb? Oh, well, you know, the story of Vanilla Sally, Growling Lambs? No? All right, fine. I'll just, I mean, really, it's not that. It's really about using vanilla Scala and compiling it to native code with GraalVM and running it on AWS Lambda. That's the real takeaway here. Vanilla, Scala, GraalVM, Lambda. I just thought I'd make it kind of fun, you know. Vanilla Sally and Growling Lambs? No, vanilla Scala and Graal and Lambda. Hopefully, you'll either walk away from this remembering vanilla Scala and GraalVM work great with AWS Lambda, or you'll be thinking, what the heck was that stupid fairy tale that guy kept telling us? It makes no sense. So vanilla Scala works great. If you compile it to GraalVM and run on Lambda, you get high-performance serverless. Here's a breakdown of how this works. So first, you write your Lambda functions in regular Scala, use build.spt, you know, set it all up, have these nice endpoints. Then you go ahead and package it up with something like SPT assembly, which builds all of your jar dependencies into one big jar file. And then you get GraalVM, and you run the native image app, and it compiles it to native Linux Executable, which is a great part of GraalVM. Now you don't run this in the JVM, you actually have like you have Linux code. Then you could use something like Serverless or SAM and set up an AWS Lambda function. Have it run behind API Gateway, maybe fed by events from SQS, and you're all set. Make sure to give it lots of memory. This works much better with memory. And then deploy it. These are the 5 simple steps for serverless high-performance apps written in Scala. Guaranteed works every time. So, oh, I just gave it away. Okay. So if you can remember this part, vanilla Scala, and I know I'm giving it away really early in the talk, and that's pretty crazy and all, but then you'll be able to write high-performance serverless functions. So that was good. Thanks, everyone. Let's find out if there's more cookies left. No, okay. There's actually, you're supposed to start with a problem and then go to the solution. I realize that normal talks, you're supposed to talk about the problem, right? I mean, and then go to the solution. Okay, let me try this again. Here's the problem. I kind of want to write a Slack app. Who uses Slack here? A lot of people, yeah. And who doesn't want to write a fun Slack app? Specifically, I want to write it in Scala, because Scala is kind of fun, right? It's kind of a great language to write it in. So I want to have a Slack app. I want to write in Scala. Oh, yeah, because I'm doing it myself. I don't want to spend a lot of money, so I don't want to have this in EC2 or some other dedicated service. I want to use something like Lambda so that it can scale way up if there's lots of traffic, and it can scale way down to 0 and not cost me anything if it's not running. So I want a Slack app, I want to write in Scala, and I don't want to spend a lot of money. That's kind of my problem statement there for the whole talk. I went ahead and chose running Scala on AWS Lambda. I'm pretty familiar with AWS. I think it's pretty cost efficient. You can actually stay on the free tier most of the time if you're just using Lambda, which works out really great. I also really like the serverless framework. It lets you, it's cross-language. It lets you set up a YAML file with your whole configuration. You say, here's my endpoints. It does all the cloud formation. It sets up the the stack. It sets up the API gateway. It can have SQS events sent in and trigger your Lambda. It works really great. This, for me, is like the perfect setup for writing serverless apps in Scala. Okay, it's kind of a Twitch thing. It means seems good. All right, so this seems good to me. This works pretty well. Hard part here is if you write a Slack app, you're supposed to return a response to a user interaction in less than 3 seconds. Someone clicks on something in Slack, they click on a button, or they click on a link or something, it goes out to your app. You have to do everything and then trigger the response within 3 seconds. So you have to get that back. But even more important than 3 seconds, according to Jakob Nielsen, if users click on something, it takes more than a second for something to come back and show an interaction, they kind of lose the user flow. A good user flow, you have to have something snappy and responsive in less than a second. Even more so, if you want to make it look like it's instantaneous, like I clicked and something happened, you have to have a response time of about 100 milliseconds or less. So you really have to make this snappy. So if you're going to have a serverless function which is going to drive a UI like a Slack bot or a interactive Slack app, you have to have really fast response times to make sure users are going to want to use this. So you're probably curious. Okay, so where's the issue here? Issue here is that JVM, when you run on Lambda, is kind of a slow solution, and it doesn't really meet the needs for getting this into, let alone getting this into 100 milliseconds. It doesn't always meet the needs for having a snappy user flow in less than a second. It may not even meet the needs for returning less than 3 seconds. It's kind of slow. Core thing is, someone's calling your Lambda function over and over again. The response is pretty good. What happens when no one calls your Lambda function for a few minutes? Does anyone know what happens then? Yeah, it shuts down the JVM. So someone has a call coming in, the endpoint comes in, Lambda will have to start up the JVM. That takes extra time. That's known as the cold boot. And it's chilly, yeah. It's really slow, and this is a huge problem for any of the JVM languages to run them in serverless. I did some testing with different sizes with a pretty basic serverless app that does a little computation, mostly returns. One thing that really works well is memory. Apparently if you throw memory at it, or if you throw money at it, and you run with more memory up to the limit of 3 gigs, which is the max right now with AWS Lambda, the cold response times really goes down a lot, but still not really that great. If I layer on top of this the slack time for responses and realize, even if I have like, say 2 gigs of memory, I still want to do things. My Slack app may need to call other APIs, maybe call Stripe, maybe call Slack APIs. Those take half a second. It's pretty unlikely I'm going to have, in every case, return in under 3 seconds, let alone try to have a good user flow where people stay in the flow and do things. It's kind of impossible with just pure VM, with a pure JVM. All right, which brings us back to the tale of growling lambs. Yeah. All right. So who hasn't heard of GraalVM? Oh, all right. So this is an Oracle project. It's been a full release. It's an alternate VM for running a number of different languages, Python and Ruby and many others. But it's also a way to take Java apps and compile them to native code and run them with some restrictions in such a way that you get really fast execution time. This is taken from the GraalVM website itself, and it's true. If you create a native image with this, you get really fast startup times. Here's an example taken from their site. You can see that I have a 90%, I save 90% of the time by taking this bytecode, compiling it to a Linux executable, which then includes the Graal runtime VM itself. You get much better startup times. You kind of kill that whole JVM startup time issue that we see a lot. All right, so AWS Lambda, it works with like Python and Go and JavaScript and Java and Scala, calls entry points. Works a little differently when you use Linux executables. You can use Linux executables in AWS. It has something called the custom runtime environment, where they have a base Amazon Linux. It does have Java, a few other things, but you're supposed to have a Linux executable. You compile it, it starts it up. you do a HTTP GET to say, hey, local server, what's the next request? And it whenever someone calls API Gateway to get to your function, it then returns this whole JSON, which says, okay, here's the whole API Gateway, here's the query parameters, here's the headers, here's everything that comes in. Same thing if you have SQS events which trigger your Lambda, you have to have basically an infinite loop that just calls this local thing, gets the response. If you have a response, you have to then write it back to the same URL and then call it again. It's a little bit funny, but it does work. I mean, you could use pretty much any language. This is what I use with GraalVM. I have a native Linux executable, and I just call this over and over again. I'm using an older version of the GraalVM. I do the compilation in Graal in Docker because AWS Lambda custom runtime is Linux, and I'm using a Mac. So if you're on a Mac and you want to run this in Linux, especially in AWS custom runtime, you pretty much have to cross-compile this in a Docker file. But this works really well for me. Oracle has a number of them available. Here I'm saying, yes, I want to do native image. Here's my big fat jar file that I built. I do want to do certain types of networking, HTTP and HTTPS, and it sets up this image for me. The other thing I have is my core build script. I'm using SBT assembly to say, okay, go in and test it out, and then run assembly, build all the dependencies and transitive dependencies get put into one big jar file, and then I run the Docker and get the output. And then I zip up not just the output, the Linux executable, but you can see I'm including CA certs and libsunik. These are two JVM files that come with the Linux JVM that make it possible to do HTTPS. This makes it possible to do the security necessary for supporting certificates so I can have an HTTPS client that goes out and works properly. So this is kind of a hard step, but you have to do that if you want to have a Linux executable running in AWS Lambda in the custom runtime from a Java program. Fortunately, when you then run this, the response times are pretty great. You can see that cold start times, and I'm not sure why the 256 one, I kind of want to run it again to measure it, but all the response times are under 250 milliseconds pretty much for cold starts. Warm starts even better, and to be honest, when I run this, I usually have response times of about 50 to 80 milliseconds. Someone clicks something in my Slack app, it calls back to me, I do some things, I write back. Completely finish, even doing a blocking write back to Slack usually takes about 80 milliseconds total. AWS then charges me for 100 milliseconds of it, very cheap. It stays on the free tier. Very fast turnaround time. I mean, this works great. If you look at that 1 second for user flow, we are way beneath there. It means that if someone clicks and calls our app, we can go out to a database, we can go out to a queue, we can maybe call some remote APIs. We have a lot of room to work with, so we can be really fast and have nice, efficient applications that have wonderful user interface. So GraalVM and AWS Lambda work together really well. It turns out to be a wonderful match. So enough of the growling lamb, goodbye. Let's talk about Vanilla Sally, or specifically Vanilla Scala. So Scala and GraalVM, though, this works. With Scala, you can build jar files. You can then create a fat jar file. Issue is that there's a lot of problems getting this to work. This doesn't work super well. It's actually a little challenging to get your Scala apps compiled to Linux code with GraalVM. Plain Scala code works out well. Case classes and options and most things you do work pretty well, but there's no reflection allowed. One thing they remove in GraalVM is you can't do any runtime reflection at all, which actually means there's some pattern matching that doesn't quite work in Scala if it requires reflection to reflect based on the class type. So you're not going to be able to check the type of things. JNI does work, though if you're packaging for Linux, you have to remember to use Linux libraries and link with them instead of Mac libraries, because it depends on the runtime environment. But loading classes dynamically doesn't work at all. The GraalVM wants to have everything set up and initialized at build time, not at runtime. Runtime, you're not allowed to load classes. What this kind of means is that you can use some pure Java libraries like Apache HTTP components from, I think it's 20 years old, but it works great. It doesn't do any class loading. I would love to use Scala HTTPS things like Akka HTTP and such, but they all do some type of either reflection or dynamic class loading, and they just won't work in Graal. JSONiter is a great JSON solution. It works really well, extremely simple. You can choose to use it with implicits or not, but it doesn't do reflection. It's great. I believe most of the other Scala JSON libraries I tried did do some type of reflection, and then they didn't work in GraalVM. So this kind of gets back to the idea of, well, you kind of have to do things yourself. Use as few libraries as possible. Handwritten API clients, if you're calling a REST API, write the code around Apache components, set up your own options, use try, use all the Scala things you like. But if you do it yourself, it works great. If you use things if you use other people's API clients, I think I tried Stripe and a few other different API clients, I couldn't get them to work. They all did some type of reflection or dynamic class loading underneath. For AWS, I did need to get AWS on SDK for Java working, so I could do things like call Dynamo. I did find there are ways in GraalVM to say, okay, there's something which might need to have some type of dynamic initialization. I'm going to call it out by name. This is an internal JVM class. This is used indirectly by AWS. And to make sure GraalVM doesn't have errors when I build it, you have to call some things out directly. So a little bit hard to deal with. Core thing to remember, though, is, no, not this, but vanilla Scala. If you have plain vanilla Scala and you compile that with GraalVM to Linux Executable, that works really well. So that's what I want you to remember, more than the silly fairy tales or the really beautiful typography of this presentation, is this part. This is the key to success for high performance serverless applications, at least with AWS Lambda. So I think that was actually pretty good. I'm near the end. Oh. I forgot to introduce myself. You're supposed to do this at the beginning, right? All right. So, hey guys. Okay, another Twitch thing. So I'm A Swartz, and I like to work with Scala, and I've worked with it a number of places, and I like working with technology and engineering, and I'm at Twitch right now wearing the Twitch logo thing. We don't really do Scala, and they don't let me code anyways, so it's kind of fun to do Scala things on the side. It's a really fun language to work with. I've been using Scala for about, I guess, 7-8 years, and it's been great. I've worked with Alexi on this Scala by the Bay and SF Scala, and it's really fun. So it's great to come here and talk about this and share what I learned here. I'd be happy to talk about Scala or any of these companies or being at Twitch or anything like that, or video games. So please come find me, and I'm open for questions now.
Question?
Yes, sir.
So how good are the error messages when something is going to be dynamically loaded? When do you know, and how easy is it to spot it?
Fortunately, I found all the issues while running this locally in Docker as a test. You can certainly, since it's just a Linux executable, I would just have a separate Docker file to then run the Linux executable, see if it can start up and call a local HTTP URL, and I'd find it pretty quickly. A lot of the cases you find this at compile time. GraalVM is really good at looking through and saying, okay, this is using reflection, or this is going to be dynamically loaded. But there were a few cases where I actually then had to run it locally in Docker to actually see it fail, and Graal say, whoa, I can't run, you're trying to do something dynamically. I showed reflect_config.json. There's a number of different ways that you can say, hey, take this thing which is trying to do runtime initialization and do build time initialization, so it pre-initializes it and then gets it ready. But I found it's really hard to get that working for most things. I tried with Akka, and I tried with, I think, Circe, and I tried with Akka HTTP, and all the really cool libraries I couldn't get to work. Yes?
I haven't used Scala native, but have you looked at it at all?
I haven't. I like Graal because it was new and shiny, and really good docs, and the native image, the fact that they had the Dockers ready with the type of Linux made the cross-compilation super easy. Yes.
Hate to be that guy, but this is more of a comment than a question. Apparently, Argonaut goes to great lengths to avoid reflection, so it might be usable in Graal.
Argonaut. Yeah, I think Argonaut does some work with. I think I've seen articles on Argonaut and Graal. Yeah, Graal's great. It's really interesting how they said, okay, if we don't do any reflection or, runtime type introspection, it turns out we can actually run this as a native executable. Any questions from this side of the room? Their questions were that good? That's all right. Oh, yes, sir.
How good is detecting if some library will work? So I have some cool Java library, it works. How would you know that it works?
I would compile it in, initialize it at runtime when the app first starts up, and build it into Linux Executable and try it out. Graal is pretty good at checking and verifying that there's going to be some type of runtime initialization, for example, use of the JVM things like class.for instance or other type of JRE for runtime introspection. So it does a pretty good job searching through those. And it's about a 2-minute compile so it can take some time to do it, but I would just say try it. The hard part is, in many cases you'll have to get the most vanilla basic solution. Yes? No, what is Cloud State?
It is Jonas and Victor's project that is trying to build a framework for stateful serverless. It's pretty interesting. It's very young.
Nice. Is anyone talking about that at the conference? Cool. How much more time for questions do we have? 2 minutes or 2 questions. Yes? You mean decrease the response time? Well, let's see if I'm still. Let me go back to my measurements of actually running these things. Throwing more memory at it works pretty well. If you run it with 3 gigabytes, AWS does charge more for this, but for some reason, I'm not sure if it's cached or it just keeps it running, but the cold start time it's over a second, but it works pretty well. It's possible that if you go to Google Cloud or you go to Azure, I don't know if they have the exact same issues. Some of this might be dependent on the implementation of AWS Lambda. We have time for one more question. No one wants to know about the silly fairy tale? Yes, and back.
A collection of libraries that you have tested that you have available online somewhere that you share?
It's just Apache HTTP components and JSON-iter Scala, and that's it. I have a very clean, happy build.spt. I couldn't get anything else. That and AWS SDK. So JSON-iter Scala, Apache components, and the AWS SDK, though I did have to do some JSON configuration. I'm not using anything else. I just found making my own Scala type HTTP wrapper with tries, with my own response body, with a fast JSON back and forth. It works so well. I love having tries or returning an either of either a message or an error object and handling it with pattern matching. I turned out to be pretty happy just using these very base components. All right. Well, thanks everyone. I'd be happy to talk about any of these subjects in the future.